cool animation. But hey everyone, thanks for joining. My name is Kaushik Murugapupathy. I'm the Prisma Cloud Solution Architect. I work for Palo Alto Networks, and my product specifically is a cloud-native application protection platform. How many people have heard of Prisma Cloud? Raise a hand. Yes, internally. Okay. And what about Cortex? The Vickers? Yep. Okay. This one time. So what I'm going to be talking about is sort of, we're bringing the best of both worlds, the Cortex platform and the Prisma Cloud platform, kind of merging them together into a single unified agent. This is sort of the next wave of security that we're seeing and how we're going to be tackling. They're not. On today's agenda, that's fine. Today's agenda, we'll talk about current state of the cloud. Then we're going to talk about how we look to address that and what we're seeing in the market today. And then finally, I'll talk to you about what we're rolling out on the CDR front. CDR stands for Cloud Detection and Response. 2025, we'll see 750 cloud-native applications being deployed in all the clouds. So this is a massive increase year over year. We continue to see this trend to increase over time. From those incidents, from vulnerabilities that turn into incidents and exposure, 80% of all vulnerabilities is in the cloud, meaning more and more bad actors are attacking cloud-native applications. That's a 66% increase in cloud attacks. Type of questions every day, I talk to CISOs, I talk to new customers, existing customers, and I tend to ask them about the cloud security, their posture. Are they satisfied with it? What kind of metrics are they looking at? I talk about what toolings do they have? Who has access? How are they monitoring access and control? Are they able to identify if they've been attacked? Or do they even know if they've been attacked? What kind of mean time to remediate, mean time to detect type of policies and SLAs do they have in place? And how are they tracking that? And every single time I get an answer of, we have a product for that. We have a product for that. That's sort of the norm that we're seeing in cloud today as well. So it's a norm on-prem, and that legacy mindset is translating into the cloud. The biggest issue there is these are all point products, and point products are really good at a single use case. However, what we're finding out is a lot of companies are struggling with the alert fatigue. I used to work at the Bank of Montreal. I led the cloud orchestration platform team, and we had about 60 plus information security tooling in BMO. CIBC, I imagine it's the same thing. It was impossible to actually correlate alerts. Every alert was disjointed. We were playing catch up, and the bad actors are winning on that aspect because we're not remediating the alerts. It's at that point, it was simply noise. An alert without context is noise. So that's what Prisma Cloud and Cortex is trying to bridge together, is we're trying to correlate all these different alerts, and we're turning it into a platform. So one platform we're able to remove some of these point products and then bring everything together and provide that correlation between what an application IEC vulnerability is to runtime vulnerability. The type of attacks we're seeing and on an increasing basis is ransomware, cloud exposure, nation state type of attacks. And what's not mentioned here, but the underlying root cause of most cloud attacks is identity. If you look at all the biggest attacks, Capital One, for example, the root cause of that attack is an over-permissive firewall. So if you're not monitoring identity, you're subject to it. It's easier to do a lateral move with an over-permissive role. And then you could go around into the cloud, your cloud estate. And then what do bad actors want is data. From an over-permissive role, you're able to get into an S3 storage account, data warehouse, and so on. And this is a problem that we're seeing, is we know that this is what bad actors want and where our sensitive data lives. However, our SOC team, Cloud Security Operations, they don't have enough data. They cannot remediate cloud alerts because they're very limited in cloud effective visibility. What that means is they're used to endpoints, laptops, mobile devices. However, in the cloud, there are different types of hardware, whereas it doesn't translate, and they lack the insights from the cloud security teams to effectively remediate some of these alerts. With CDR, we look to bridge this gap. So we rolled out back in April of 2024, we introduced the concept of cloud detection and response. So what it is we have two platforms, Prisma Cloud, Cortex. Why install two agents? We're going to have one agent between the two platforms, and all the alerts from Prisma Cloud is being flown in as telemetry data into the Cortex platform. What we're able to achieve is we're the only vendor to achieve 100% prevention in MITRE attacks with no modifiers or no configuration changes. We're consistent across all vendors. So whether you're in on-prem, GCP, Azure, OCI, IBM Cloud, whatever it is, we're consistent in that aspect. And then we're also consistent in the actual workload itself. So if you're using containers, serverless, actual virtual machines, endpoints, Windows, Mac OS, whatever it may be, we keep that consistency across the platform. And we're easy to deploy. Within minutes, we're up and running, and you're able to get full visibility into that workload. How this is all played out and how we're able to achieve this. First, we need to understand the workloads in the cloud and their tendencies. Cloud infrastructure are disposable in nature. So let's say you have an application. An application gets spun up based off demand. And because of that, it doesn't make sense to just monitor that application. We need to shift our focus, shift left into the actual code itself. And that's what we're doing here, is oftentimes when you see a vulnerability in runtime, it originates from an actual misconfiguration in the IAC templates that's situated in a DevOps repository, in your version control system, whether it's GitHub, GitLab, or Atlassian, Bitbucket. So we need to shift our focus from just runtime, protecting runtime, to the container engine, and also to your infrastructure as code. Think of the Cortex platform as your console for identifying and investigating a threat. And then the Prisma Cloud Console, where you want to be at after you've identified the threat, is to ensure that it doesn't reoccur. So we're not only fixing the actual incident in real time, we're identifying the root cause because we have full visibility across the landscape. How we achieve this is by first shifting left. What's the furthest left is your developer's IDE. Here we have a native extension into the developer's IDE. They're able to install it through IntelliJ or VS Code, and it's essentially a Python script that runs. There are all of the policies, organizational policies. We have about 5,000 policies, and we have the ability to create custom policies. That gets brought in to the actual developers. So we're putting the ownership of security to the developers. So as you're creating infrastructure as code, we're continuously scanning that and ensuring that they're developing more a secure code adhere to the organizational standard. Once that code is secure, the developer is happy with it, they push it. They push it to a master branch, a branch where there's other developers working together. So in order to stop the poisoning of that branch, we continuously scan there as well. So we integrate with your GitHub Actions, your GitLab commits, or cloud native CI/CD tooling. There, we're able to do what we call enforcement rules. So we know that not every application or environment is treated equally. For instance, prod, you want to be more strict. So within a prod application, if I actually see a vulnerability that's critical or high or medium, I actually want to block that from being deployed. And if I see a vulnerability in my non-prod environment that's just critical, I could block that. Reason for this is I don't want to be an impeachment for the developers. I want to work with them. I still want them to be agile, but I want to put the ownership of security on them. So we're able to actually block builds. We have full hard fail, we could do soft fail, and we could do informational. Reason for a soft fail is the pipeline continues to build. However, the developer is responsible for commenting why this vulnerability was introduced. Reason for that is, let's say a version of a specific Python package that is known to be vulnerable and you're not choosing the latest is being used into your pipeline instead of the latest. And the reason for that is for application compatibility. That's a fair reason, accepted risk by the organization. So once that's secure, the pipeline, we deploy it and we can choose to monitor in runtime. So within our cloud risk pillar, the middle one, that brings in the CI/CD security of the actual images. So we're embedded into that lifecycle, so that Jenkins build that you may be using, where we're continuously scanning that golden image that we call. So let's say there's a vulnerability in one of those golden images. That golden image gets deployed hundreds, if not thousands of times. Instead of fixing that one vulnerability in your CI/CD run stage, now you're left with hundreds or thousands of vulnerability. That's far more expensive and more detrimental to the organization than just fixing it in your build stage. So all of this data is coming in to the Cortex platform for a SOC team to remediate. So the SOC team now has context into the nature of the application. They're able to prevent attacks before they escalate. They're able to detect and prioritize threats using AI. And I'll talk about AI. It's not just a keyword here, where we're actually using it to prioritize some of our alerts. And the biggest thing is speeding the investigation and providing our analysts with insights. How that AI-based prioritization works. Let's say today, we're collecting data from a bunch of sources. So from Prisma Cloud, one of the main data feeds. Then we also have endpoints, identity, network, third-party data sources. Third-party data sources could be like a Snowflake, a Databricks, Office 365, SharePoint, as well as AI-based detection. We take all of these disjointed alerts and we put them together using, we have about 5,000 detectors and over 2,000 models, AI models, where we're able to take disjointed alerts, add context to them, and we're able to prioritize the severity of it. And what we do is provide a risk score, and that takes everything into account. What we are able to achieve is a more accurate detection and remediation playbook. So I talked about the shift left approach and how Prisma Cloud is able to achieve that. And I also talked about AI prioritization. So this is all great, but in order for us to scale, when working with a large organization like a financial institution, we need an automation. We need effort in automation. And then that's the next step. We have 1,000 plus Cortex XIM playbooks available for your consumption. And then we also could work with you on building playbooks more specific to your organization. Our playbooks are AI-driven, so whenever it's run, the remediation is captured. We capture your environment details, and then we're able to improve upon the automation for the next time. So we're continuously learning. What we're able to achieve by doing this is a 90% reduction in mean time to remediate. Mean time to remediate, we're able to bring that down from days to now seconds. And also, key thing is 70% less work for your analyst. So if you've ever been to the Palo Alto headquarters, whether for an EBC, talk to your account rep and make sure you have the SOC tour. You can see some of our SOC, the theater that we call it. It kind of looks like an image from Minority Report or air traffic control system. It's quite impressive, but that entire operation is run by 5 analysts. Our Palo Alto SOC, which is, we're the biggest standalone cybersecurity company in the world. We're the target of nation state, every bad actor out there. But our SOC is protected by 5 analysts, and it's because of automation. Everything is automated. Everything is playbooked and indexed, and all the context is provided to our SOC team. And here's an example of exactly that. So this is an actual screenshot from the Cortex platform. At the very top, you're going to see a score, 90%. So that's sort of the rating of prioritization in your organization. You're able to see how it rates this particular vulnerability. This is that log4j vulnerability we all are pretty familiar with, but that's just an example. Like, there's going to be another log4j. It's just a matter of if and when. So what we're able to do is correlate 38 alerts from 5 different sources. Traditionally, 5 different sources, 38 alerts, that's 5 different dashboards. That's 5 different point products where I need to go to and remediate these alerts individually. What we're able to do is correlate all of that into one, and we made a suggestion of 3 playbooks to run. So your analyst has an option of picking which playbook best suits their environment. And then before we ran that playbook, we took 14 actions in preparation for your environment in order for it to run these playbooks successfully. So that's a whole picture of how we're able to kind of achieve that mean time to remediate from days to minutes. On the back end, how this is all possible. It's through our attack paths. Attack path, if you haven't heard about it, it takes disjointed alerts and provides context to them and correlates them together. So here's an example of that same log4j vulnerability. Here's your EC2 in the very middle, right over here. And then over here on the sides are 2 vulnerabilities that were detected. These vulnerabilities are medium in severity. So today when you see a medium severity, there's not much urgency. Like, there's critical and high where, like my team, when I was at BMO, that's where they put their effort every day when they come in. They sort, do the filter sort, and go critical and high. That's where the effort is going. This medium severity, it probably won't be looked at in maybe when we catch up in like 2-3 months. But that doesn't tell the whole story. Just looking at the severity level does not give out the whole story. The attack path is trying to look at everything, all the telemetry data coming in. So from that, we've identified that this medium severity EC2 instance on your left, it has an overpermissive role. This overpermissive role has access to an S3 bucket. This S3 bucket has access to sensitive data. Using our DSPM, our data security posture tool, we continuously scan your environment's data to ensure it doesn't have PII data. If it does, it's configured correctly. So this is our DSPM working. Our our DSPM tool working there. And then we're able to identify that this EC2 now has access to that through an over-permissive firewall. And then over here at the right, you're gonna see that a potential attacker right over here. So to make matters worse, this EC2 has port 8080, port 443 open. So it's open to the world, port 22. So all of these are potential attacks surface where a bad actor could actually infiltrate this EC2, gain permission, heighten their permission from the EC2 in order to view the S3 bucket, and now has access to your sensitive data. So we just turned this medium severity alert into a business critical alert because of that sensitive data. So that's the attack path working all together, where we're able to identify exactly where and how an alert is being triggered. And then at the bottom, you're going to see a summary. So with all of our alerts, we provide a cause and effect. So the cause, we see why it matters. And then the effect is what could happen. Because when I speak with SOC teams, when I speak to cloud security engineers, that's the biggest pain point is, why does this matter? It's just noise at the moment. But if something bad doesn't happen, it's still noise. Until something bad happens is when we start taking it seriously. But we're looking at potential attack because eventually something will happen. So we provide that cause and effect with every one of our alerts. And we are able to take it a step further because we know that remediation is super critical, especially in the cloud, the way we develop. We have a button at the very top that says fix in code. Because when I mentioned that shift left, we're scanning your actual application, the actual code itself, we're able to see that there's a misconfiguration on that code. So we implement a fixed in code button. From there, I'm able to generate a pull request. That pull request will be given to a new branch will be created. So just say it's in GitHub, a new branch will be created. And as the branch owner, the DevOps manager, the DevOps lead, I simply review that branch, the pull request, and I merge it. And when I redeploy my Terraform application, Terraform module, that vulnerability is fully remediated from the source. So we don't just remediate it in runtime, because when we fix it in runtime and not the source, it's just going to reappear. So we're actually able to generate a pull request that fixes the source. We automate the actual fix, and that's what you're going to see here. Here's another view of that actual Cortex dashboard of all of the data sources. So we have all the public clouds as well as identity coming in. So that's 2,500 alerts coming in. We're able to correlate them into their like relationships. So it's a many-to-one relationship mapping. That brings us 100 incidents. From 100 incidents, 80% is automated. So that fix is automated. 20% is a manual fix. Type of manual fix is, let's say a secret is exposed in one of a developer's code. There's no real automation fix here. It's a developer has to actually go in, create a Terraform vault or a vault file, and then call the API, and then attach a variable. So that's an example of a manual fix, which at the moment is not possible to fix that automatically. So what we see here is we're able to achieve an 88, so about a 87.5% reduction in incidents just through an automated approach. We're recognized as market leaders, our CDR. MITRE ATT&CK, we're the most efficient in the detection ingenuity, according to MITRE. Forrester has rated the Cloud Detection Response Agent as the leader in the Gartner Magic Quadrant. We're the only 2-time Forrester winner in cloud security workload protection. So that's our workload protection CWP application. And then XDR leaders as well, according to Forrester. What our customers are saying about the new agent. I'll give you a second to read that. And another interesting read, especially CISOs at the summit, that you could find interesting is our Unit 42 security assessment. You just search it. It was recently released, 2025. If you're having trouble, just come see me after the presentation and I could send it to you. But it gives you an idea of what we're seeing today. Unit 42 is our in-house threat detection analysis engine at Palo Alto Networks. We work with every 3-digit acronym in the US. And they put a report every year on what they're seeing and how cloud security is kind of changing over time. But yeah, I mean, I want to use, so I purposely left a bunch of time on, so we could have a conversation on what we're seeing today in your organization. How is cloud security treated? What are you using today? Are they effective? How are you measuring success? And what are some of your pain points? If there's any volunteers, happy to go for it. Vivek?
Yeah, no, good presentation. I like what you said about code.
Yeah.
Form fixes. Now, you try to do it all. I'm like, oh, sure. I'm shy and quiet. Okay. You're trying to do it all. So what's your view in terms of the code journey? Does it have a branch into Veracode or other tools like that? Or is Palo Alto going to take care of it all? Like what's not necessarily where we are yesterday, but where are we headed to?
Yeah. The roadmap for organization is consolidation of security tools. That's 60 plus tooling, infrastructure, information security tooling is not efficient. We've seen that. I've worked at BMO. You're at CIBC. You could test to that. It's alert fatigue, and everyone is suffering from that who has more than a handful of IAC tools. So we need to consolidate. Point products are good to address a single use case, but they don't talk to each other. Like my Qualys agent is not going to talk to my CSPM Azure, my Wiz CSPM. So because of that, I'm not able to correlate these alerts. I'm not able to identify the root cause. So that's why our CEO, Nikesh, coined the term platformization. That's where security is heading. Yeah. Yeah.
Literally.
Yeah.
I'm just talking about code.
Yeah.
Zoom in on that for a second.
Right.
I'm just zooming in on the code review step.
Yeah.
And you're feeling good about where Palo Alto is in terms of its quality of the code review, be it application or Terraform, and it's sufficient to displace, trusted tools like Veracode.
Yep. Good question. So the way I take things when I talk to customers, transparency is my philosophy. So in terms of IAC code, yes, we're able to displace any IAC temp code. When we're talking about application code like SaaS and DAST, not today. So I wouldn't ever recommend our customers to turn off their sneak that they're using for SaaS and DAST, because our solution it's not there yet. It's in our roadmap, but we're not going to displace SaaS and DAST tools. IAC 100%. So within our IAC, we're benefiting from the platformization. What I mean is, first we look at what we call binary fixes. Binary fixes are pretty simple. Every IAC scanner does that. So let's say an EBS volume I'll use primarily GCP. So an volume, a storage account is unencrypted. It's easy to fix that. like every scanner knows best practice, encrypt everything. So they were able to find that. However, with our tool, we have something called the smart fix. So let's say my application is PCI compliant and it's at the very top. All of the PCI policies are enforced. In order for that application to be PCI compliant, it requires the storage account to have a 90-day log have a 365-day log retention. My developers may not know that. So they're building code with a 90-day log retention because that's a default in most cloud providers. But because the actual origin, the policy engine at Prisma Cloud knows that you're PCI compliant, we'll provide that fix. We'll tell the developers. So we're taking a global compliance standard and we're pushing that in to the developers as they're building code. So in that aspect, our smart fixes will benefit the customer. But when we're strictly speaking on application code, SaaS and DaaS, no, we won't displace that. Good question. Anything else? Anyone else?
So I had a question around what you mentioned on, I guess, any of the automation piece on remediation and like how it uses AI to kind of learn how to do it better in the future. So like, what exactly is it looking at from the remediation in terms of like mistakes, or like, what is it saying? Okay, this is wrong. I can't do this next time.
Yeah. So we proposed three. On that example, we proposed three playbooks. So today we have over 1,000 playbooks in our XIM platform. XIM is the automation bit of the SOC. So that's a platform, like a specific module within the XDR. There we are continuously developing new and new playbooks. So whenever you run a playbook as a SOC analyst, that's a manual effort of actually clicking to run the playbook. The model, the actual engine, is learning on what the response was, what changes were made. So the next time you run that playbook, so for instance, your environment is really important, context. So when you run it in a prod application, like how much downtime can you afford for your organization? So that's all monitored and metrics. If it's a non-prod application, you know that there's a longer SLA requirement and it's less of a compliant issue. So we're learning all of that stuff. So when the next time you run it, we're able to identify which application, which environment it's run on. We're able to fix our automation based on that.
Does that happen, like, I guess, as soon as the automation is ran, like the next time it would just be like fixed, or is that something they have to be presented as a developer and then go and...
Yeah, there's like with anything, there's a learning period. With a platform like Prisma Cloud and Cortex, like when you first onboard it, that first 24 hours is a learning period. What we're learning is the behavior of the application. Like if I have an application that's talking to a database on 1433, and then that's the application's behavior for a number of months. And then all of a sudden I see port 22 open and I see bidirectional traffic going out of port 22 into an IP that might be malicious. That's an abnormal. That's our anomaly detection at work here. So we're able to identify that's an anomalous behavior from the application's behavior. Like usually it talks about 1433. All of a sudden we see port 22 open. So from there, we're able to identify exactly what is anomalous. And then that's where our playbooks is running, where we notify our SOC team, this is an anomalous behavior. Let's block it. And then we could also block it as well. So we could take the approach of detection, prevention, and then block.
Thank you.
Yeah, no problem. I know I got the 1 minute signal, but if there's any other questions, yeah, come see me. And I'm happy to share that Unit 42 report with you guys. Yeah, thanks for coming.